Hello everyone. I'm here to present my thesis work done here in Tecnimont with in Milano. So the dissertation topic is integrating building openings into BIM workflow management for optimal MEP detailed design. Going straight into the introduction of the work. The introduction is based, for example, in upon the 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 industrial plant projects or the organizations which deals with the EPC design. So the engineering and the procurement and the construction work. And for example, these organizations can work in the for example in the industrial plant projects, and these projects because of the huge size of these projects, there are multiple organizations, multiple departments involved to carry out this work, and these different organizations design different fields for these projects, and these different type of work also contain MEP detailed design in these industrial plant projects. So for these MEP equipments or for these MEP design, we need to provide the openings in the building elements, for example, the walls and the floors and the slabs or the ceilings. For these openings, to provide these openings, we have to properly manage these openings in an efficient way to optimize the time, looking at the project complexity, to optimize the resource allocation. For example, if we mismanage these openings, provide them at the wrong locations, and the construction is already the constructor already cast the part of that building with those openings in the wrong location, that can cost us a lot of money and a lot of time, repetitive work. So the objectives of my thesis work was to create the as-is and the to-be workflows for the organization. And then we have to, for the to-be workflow, we have to also find out which kind of inputs do we need. So with 3D, we have to go from the 2D inputs to the 3D inputs. We have to also automate the process of providing these openings. So the work of automatization. Then we have to also give the outputs to different organizations in the 3D form. We have to also look for the best way to collaborate and coordinate inside our department and with other departments as well inside the organization. And we have to also get the approval of this proposed workflow from the organization. So first of all, starting with the departmental organization or the breakdown of the organization structure inside our organization, which was Tecnimont here in Milano. I was working in the building department, and the building department consists of architecture, mechanical and plumbing, and electrical and instrumentation subdisciplines. And these subdisciplines were then further divided into different sub departments. For example, architecture, plumbing, system, HVAC, electrical, all of these were working under one department named as building department. So we had to collaborate with all these different departments. Then we have the core departments of the building. So the building departments mainly focuses on the architectural design and the architectural elements of the project, and then the core departments will do all the design of all the industrial plants of all the industrial plant projects, whichever item is included in the design. They include civil department, instrumentation department, piping department, which is a very important department in terms of designing for the mechanical MEP design system in an industrial plant project. So I can show here my as-is process map, the as-is workflow. That is the current work procedure to manage the openings in the building system. So we will discuss we'll divide these workflows into parts. So from the left side, we start the activity, we get the inputs, we place the cutouts in the middle, and then we provide the outputs. So I will explain this workflow moving on in the next slides. And the 2B workflow is here. We have to change the input methodology from 2D inputs to 3D inputs in BIM, and then we also have to provide the 3D outputs to different organization. So these will be explained in the next slides. The methodology of my case study is that first we have to get the inputs from different departments. So there will be 2D inputs. We have to convert them into 3D inputs. We have to find a way how to convert them into 3D inputs. Which 3D inputs do we need? Then we have to provide the openings into our building model, architectural model, and then we have to do the collaboration to find out the clash detections and the mismanagement of the openings. Then we have to provide the output, which were in 2D and as is model, and we have to convert them into 3D outputs to different departments. And then we have to go through the approval of the proposed workflow, and then these some automation techniques that we can use for the cutout placement activity. Cutouts are the other word for the openings that are provided in this building elements. So we can see here in the middle on the left side, we can see the picture of the building in which we have the 3D inputs from the different building sub-departments that we can see is the BH, BN, BU, and also the 2D different 2D markups on the drawing sheets that were provided from the core departments to get these openings into our architecture elements. So these are two different types of inputs that we are getting. One was 3D and one was 2D. So we can see on the right side that there is the difference in the workflow, and the difference in the workflow of as is and 2B is that we removed the input 2D sheets. So the markups with 2D sheets with markups are changed with providing 3D IFC models with proper input data to federate the model and then have one proper model with all the inputs in 3D. So how do we get these input? What type of input do we need in 3D from these departments? So we need what we call is a placeholder provision to show us where is the conflict or the intersection between the mechanical equipment and the building elements. So here we can see that we use Magicat plugin for this and this metadata required, and the family naming convention that we used for these placeholder provisions. So we can automatically, when we design the MEP elements and they collide with any building element, and we use this Magicat placeholder, so we can automatically get these type of shapes which have the 3D shape with the different metadata. Those are called placeholder provisions. So we need this data from in the 3D model from the other departments to get to our building architectural model, federated model, and we can provide openings on the top of these placeholder provisions. So now the cutout placement activity. So now we get the input data in 3D. How do we provide these openings? So we use simple general window family, and we have some associated properties for that, and the naming convention and different type of family and different types depending upon if it's a round shape or rectangular shape or if it's in a floor or a roof, and different types of this family depending on which department these openings are required for. And this work is both same in the as is and 2B model, and on the top, as you can see, that this step is both. So we go from the model federation to check the model, and then we check the input data of the placeholders, and then we provide the openings on the top of it. Then we can go to, after we get this model and after we have these openings inside the 3D model, we can then go and do a collaboration or clash detection check where we use BIM 360 and CDE for this all project. And then we have the clash detection. We use the BIM 360 clash detection model coordination discipline or the functionality of BIM 360 to do a lighter clash detection, just to check where either these openings are provided for these mechanical equipments at the right location or at the right size or no. And if they are not, we can, for example, you can see in this example, we can assign this to the relevant departments and to the relevant personnel of the other departments to clear out this issue. We can then go to after we have this clash detection finished, we have the model prepared, 3D model prepared for us. You can see an example. So we provide this output data in this 3D model. How do we provide 3D outputs to the other departments? So we provide different views as per their ask. So for example, civil ask us to only put the civil elements inside for their needs and with the cutouts inside them, with the openings inside these building elements, and we provide different views to different departments as per their needs. So that's the 3D output part. And so we can see the transition from the as-is model to the to-be model, where we can see on the top, and with the as-is model, we always have to provide 2D sheets to different, for example, to the vendor or to the civil department. We had to provide 2D sheets to them with representing the cutouts at which place are they placed in the building, in the building the model. So now we can just go to the 2B model on the right lower corner. We can see in the middle we have the big change of the workflow, that is to provide the 3D model with different views to all these different departments, for example, the vendor and the civil department. And the next step is we created this workflow, the 2B model, and we have to I have to get into my organization and get it approved from different departments. So we start with the building department. We get it approved from my tutor and my coordinators, all involved, and the group leader and head of department. Once it's approved from our department, it goes to the EPD department, where we can approve where we can get the approval of different plugins in the software used, and then we can go to the core departments and get their approval from their head of departments. And in the end, we get a presentation to the head of supply and design. The last step is the automatization process. So during this process, we figured out that there is one activity that takes a long time, and it's a repetitive work, that is the placement of the cutout on the top of these placeholders. So what we can do, we can have two different ways to get this automatization. We can create Revit models for the Revit federated model, Dynamo scripts for the Revit federated model, and we can also use the Tekla Magic Ed plugin, which is the whole generation for the IFC federated models, from taking into consideration all the 3D models from all the core departments and all the building departments as well. So what we can do is that we acquire in the Dynamo. In Dynamo, what we do is that we take the locations and the type of metadata from the placeholder provision. We take into consideration where do we have to provide these openings, cutouts, and we give the which type of family do we need to provide for these cutouts, and we provide it with the Dynamo script, and also with the Magic Ed plugin for the IFC federated model in Tekla. We can get the reservations placeholder data from the placeholder data model that we created before, and then we can also create the whole using the whole reservation plugin in Tekla. So this is the whole thesis project, and thank you, and I'll